All right. Algebra 2, Lecture 217 and 218, OSA 2F12. The student will use a calculator and the change of base formula to evaluate logarithmic expressions that are not in base 10. Our calculator works in base 10 for logarithms. So if we run into a logarithm that isn't in base 10, we can use the change of base formula, make it base 10, and evaluate it with our calculator. I'm going to show you how to do that. Before we get started, here's what the change of base formula looks like in general. Log of base, any base of m is equal to, if you want to change the base to some other base other than whatever this is, you take the log of this one divided by the log of this one, log b, and this c here is any base you want it to be. And because we're going to be using a calculator that easily works in base 10, we're going to change everything to base 10 and be on our way. So, okay. That's the idea. We're going to round everything to the nearest thousandth, I believe is what the instructions said. So I'll show you how this works real quickly, and then we'll jump back into the lecture there. This would be the log of the big one, so to speak, divided by the log of the base. The base becomes, we're taking the log of that. See that? And now we've changed our base to base 10. Notice I don't show the base, so this little c here is a 10. We've changed it to base from base 27. Now this is written in base 10, and I can evaluate that really easily with my calculator by just saying log of 81 divided by log 27 and round it to the nearest thousandth because it said that on the instructions. So if I can find my calculator, we'll get underway. Here we go. Log 81. There's my log button, 81, divided by log 27 equals 1.3 repeating. I'm going to round it to the third place. So I look at the fourth place, I see that it is not 5 or greater, so I'm not going to round that up. And that's approximately the value that I would raise 27 to. If I raise 27 to the 1.333 power, I'll get really close to 81, okay? So, yay. Let's go back to our lecture. That's how this is the change of base formula in general. Here's how it works. And I'm just going to do a few examples of that, and you'll be ready for your worksheet, hopefully. Evaluate, round to the nearest thousandth. We're going to say we're going to change it from base 6 to base 10. So I'm just going to take the log of this one, the big one, so to speak, over the log of the base. Notice the base gets big there. And we just enter that into our calculator and round it to the nearest thousandth. That's the third decimal place, tens, hundreds, thousandths. So here we go. Let's see what we get. Log 33 divided by log 6. We changed it to base 10. It's no longer base 6. Log 33 divided by log 6 equals 1.951 approximately. Oops. The next digit was a 4, and if it's a 4 or less, we don't round that up. If it had been a 5 or greater, we would have rounded that up. This is an approximation. And so that means if this is equal to, using the definition of a logarithm, this raised to this power has to equal that. And if you raise 6 to the 1.951 with your calculator, it won't be exactly 33, but it will be very close. Okay. So there we go. I'm going to check and see if that's right. Been making mistakes this morning. 1.951. Yay. Here we go. I'm going to change this to base 10. Pretty simple. This is now base 10, log 52, base 10, divided by log 7, base 10. That's the change of base formula. We can change the base to anything we want. I'm choosing base 10 because my calculator works in base 10. I evaluate this with my calculator, log 52 divided by log 7, or you could use the fraction bar, little function there. Clear, and log 52 Where'd my log button go? There it is. Log 52 divided by log 7 equals 2.0305. This is 2.0305. I'm rounding it to the nearest thousandth, so this is going to result in this being rounded up. And that, of course, is an approximation. So this is approximately 2.031 if I haven't made a mistake. And if you raise 7 to the 2.031, you'll get very close to 52. And let's see if I got that one right. 2.031. Yay. There we go. Let's take a look here. Basically the same thing over and over again. This is going to be log 3.1. We change it to base 10. Change it to any base we want. Changing it to base 10 because my calculator works at base 10. Yay! So I have log base 10 of 3.1 divided by log base 10 of 3. Take the log of this one over the log of that one. That's simple. So I say log 3.1. Now I just try not to make a mistake. Divided by log 3 equals 1.0298. Okay, so this is 1.029. This is an 8, so I'm going to round this up to a 10. That'll carry the 1, 3, 0, 1. So having this 8 here, we'll round it to a 9, the 9 to a 10, carry the 1. So this is what our answer should be, rounded to the thousandth position. And that's an approximation. If I haven't made a mistake. I hope I didn't. It's always so embarrassing. But it happens. That's part of math. You're going to make mistakes. When you make a mistake, don't beat yourself up. Just go back and try to find it. It's usually fairly obvious if you did something silly. And now I guess I'll check and see if I did something silly. Number 3, 1.030. What I got? Yay! Okay, last one. Log base 2 of 5.5. I want to approximate that, so I'm going to use the change of base formula, change it to base 10. Log base 10 of 5.5 divided by log 2 base 10. Can't see the base, so it's base 10. That's what our calculator works in. So now I just go log 5.5 divided by log 2. Log 5.5 divided by log 2 equals 2.459, and that won't round, so it won't round up. 2.459. The next digit's a 4, so that won't round that up. So I'm going to say that's our evaluation. This is equal to approximately this, which means 2 raised to this power should give me about 5.5. Since it's an approximation, it won't be exact. And now let's see if I got it right. It says 2.459. I highlighted the wrong one. 2.459. I'm getting old and bring down because that is correct. I just highlighted the wrong answer. There's something wrong with my brain. You can do this.